Okay, so we are on page 29, as we said. So we're part 2, beyond the basics of the design of experiments. Okay, so what are some of the things we talked about yesterday? We talked about how a design works, right? How an experiment works, right? If it's not an experiment, it is a observational survey, right? The difference between an observational survey and an experiment is treatment. We're doing something, right? That's correct, and that is called a treatment, right? You're either going to insert drugs, like I said, you're going to have them drink 20 Coke cans and see what happens, or whatever, right? Okay, so you have some sort of treatment. Okay, so what are some of the other things we talked about? Something that was very, very important.
We talked about random sample versus
Simple random sample, right? An SRS. Define, and what is the biggest definition? What is the difference between a random sample and what is not? What has to happen?
Same probability of selection for everyone.
Same probability of being chosen for that survey. That dictates whether it's a random sample or not. Okay, all right. Talked about that. We talked about some ways. Talked about stratified sampling. Not that it was all that important. We talked about it. We talked about blinding. Double blind versus single blind. Okay, and then we talked about placebo. We talked about establishing a control group. All right. So those are just some of the things that we need to kind of make sure we understand there. Today, it looks like we're talking about an observational study. There are 3 different kinds of observational studies, and it's defined on the middle of page 29, that little orange, beige, whatever color that is. What is that color? It's not orange.
That's a cream.
Cream. Ecru.
What's that?
Ecru. ECRU. It's a natural skin color. Whatever. Okay, anyway. So there's a cross-sectional, retrospective, and prospective. Okay? Prospective is the easiest one. It kind of makes sense. You're looking forward, right? A retrospective, obviously, you're looking backwards, right? Whereas a cross-sectional study is that you are in that time, you are right now, and we're going to talk about that. Okay? So the cross-sectional study, data are observed, measured, and collected at one point in time, not over a period of time, one slice, right there and then. Okay? Then you have the retrospective study. Data are collected from past time period by going back in time through examination of records, interviews, and so on. Okay. So, and then we have the prospective. Data are collected in the future from groups that share common factors, such as groups are called cohorts. Okay. So look at the perspective there on the green box on top of that there. Go forward in time and observe groups sharing common factors, okay, such as smokers and non-smokers. Okay, all right, well, whatever. So, remember when we talked about, I said that when you were designing an experiment, you wanted to make sure there were not any other factors that would affect something, and you had to design them very carefully. We talked about this yesterday, right? That you want to make sure that it's just the smoking, the effects from smoking that you're talking about, not the other lifestyles could affect the result type of thing. Okay. Those things are called confounding factors. They're called confounding factors. They're on the bottom of page 29. Confounding occurs when we can see some effect, but we can't identify the specific factor that caused it. Okay? So there could be multiple different things. There could be gender, there could be usage, there could be general hygiene, I don't know, there could be any kind of stuff, right? Okay. So in other words, you can't truly isolate that. That's what you're trying to do, right? So if you find a study that has confounding factors, that means that by definition the experiment was not designed properly, correct? Because if you design it properly, you're spending a lot of money, whatever study you're doing, right? You're spending all this money. You want to make sure that you can, in the end, say, this is it. There is a causation. This is the one that caused the result. Okay. Okay. Okay, so that is confounding. Okay, so flip the page, go to page 30. Design of experiments. Okay. In A, they have a bad design. Okay, so what is it? What are we designing here? Let me see. Blah, 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 blah. It doesn't even say what we're designing. Look at A. You have a treatment group of women, and you have the placebo group men. So it looks like you're doing some sort of drug, right? And you are wanting to establish a control group by giving some people the placebo and some people the actual treatment. Okay. Why would you not want to have all the women in the treatment group and all the men in the placebo?
They're different. Men and women are different.
Huh? First of all, obviously, this is not random selection, correct? Okay, yes, it is possible to come up with this. Highly unlikely. This is what you would call a bad draw, right? You got the bad draw. So, why would you not want to have all the girls and all the guys separately?
Confounding. In the scenario of like a drug, it could impact the women differently and the men differently, but you wouldn't know because you said it.
Exactly. So you introduced a confounding factor there, right? So you want to get rid of that, right? So in order to get rid of that, you have B, where you have completely randomized experiment. Okay? Yeah. So you would completely randomize it. Okay? And then C is what? Randomized block design. So you have a block of women and a block of men. What? Okay, form a block of women and a form a block of men. Within each block, randomly select subjects to be treated. So this actually does what? Is this good or bad?
It's great.
We did do the guys and the girls separately, but within the group, we randomly selected, right? So it is actually kind of good, right? Okay, all right. The last one is what we call a matched pair design. This is a very, very narrow scope of experiments. Okay, this is what you have is you have Alex, Bob, and Chris. You have each person, and you're going to do two separate ones. Like, let's say that you wanted to test the effect of music on your test scores. Okay, so I'm going to have Alex, Bob, and Chris take a test without the music. Then I'm going to have a similar test, and I'm going to turn the music on. Right? So the reason why it's called a matched pair is because you're using the same subjects. Okay? The same people. Okay? And that is to do what? That is to eliminate as much confounding as we can, right? The same guy, right? We're crying out, it's the same guy, right? It's not like we're testing Fabian against Abby or something like that. It's the same person, right? So we know exactly what's going on. Okay. So yeah, so matched pairs happen every once in a while, and it'll come out on the test every once in a while. That's what a matched pair is. Same person or very, very close to being same person, two different things, two different environments, see what changes, see how it changes.
So you can do like identical twins. Would that be considered a match pair?
Yes. So there are many studies that use identical twins. Okay, so you have identical twins, and you will actually separate them in birth, send them to family A, family B, see how they differ, right? If they were identical twins, you would assume that they would have the same IQ. Yet, if you do a study, you will find that those who were brought up in an affluent family versus a poor family, they will have different IQs. Things will change. This is the whole nature versus nurture thing, right? Even though you were born with the same abilities, you nurture them, different results. Okay? Which is not necessarily the most humane type of experiment, right? To separate identical twins, I don't know if that's a good thing. Okay, anyway, so that's what we have there. We have the completely randomized thing, blah, blah, blah. We're good there. We talked about that. We talked about matched pair. Matched pairs. Page 31. Compare two treatment groups, such as a treatment and a placebo, by using subjects matched in pairs that are somehow related or have similar characteristics, and sometimes even the same person. Okay, all right. Okay, sampling errors. They are giving you 3 types of sampling errors there. A sampling, again, we're in the orange/beige, whatever. A sampling error, or random sampling error, occurs when the sample has been selected with a random method, but there is a discrepancy between the sample results and the true population result. Okay. Such as an error results from chance sample. This is, again, you got the bad draw, all right? You got the bad draw. In other words, if there was a population, let's say we have a population of, I don't know, high school women, and we did the height, right? And the height was, just guessing here, I have no idea, 65 inches. Okay? This was the median, okay? And you picked 5 out of, so this Blanchett girl's height, and you picked a sample of 5, and you got 50, 51, 50, 48, 62. So if you did this, you're going to think the average is, I don't know, looks like somewhere around 53 or 54, right? Which is absolutely not true. But you just happened to draw everybody from here. Right? That's what happened here, right? Okay. So that's what they're talking about here, sampling error. Okay? Non-sampling error is the result of human error, including such factors as wrong data entries. We talked about that. Missing data entries, right? Whether it was on purpose or not. Okay, we talked about that. Computing errors, questions with biased wording. Okay, these are the introducing bias we talked about, right? We talked about that, how to introduce bias, right? And also sometimes it's just the order of questions that you put them in type of thing, right? Remember talking about this? I hope this rings a bell. False data provided by respondents. This is the 2016 election, right? Everybody thought Clinton was going to win in a landslide, and lo and behold, it went the other way. Trump won, right? One of the biggest reasons that they said was response bias. The people who were going to vote for Trump were not willing to admit that they were going to vote for Trump. They lied, right?
Maybe.
For whatever reason, they lied. Okay, so anyway, so that's what they mean here, okay? By response bias or false data, right? And so that's what so those things are the type of things for non-sampling error. Non-random sampling error as a result of using a sampling method that is not random, such as convenient sample or voluntary samples. We talked about this. Right? Voluntary sample, usually the guy has some sort of reason to want to respond, right? Convenience samples again. Oh, I need to pick 10 people. I'll just pick 10 people right here, right? You're not, everybody does not have the same probability of being chosen for that survey, right? Okay, all right. And, oh, we're done. That's it. Okay, so we are done with chapter 1. So what are you going to use to review? How are you going to do your review? Right?